Welcome to qnawire.
So here, for part A, for the vertical motion of the potato, we have that h is equaling 1/2 gt squared. This is because the initial y velocity of the potato is going to be 0 meters per second. And we know that the acceleration in the y direction is going to be positive 9.80 meters per second squared, because we're choosing downwards to be positive. We're going to essentially at different points, at different heights. So we can then say that t is equaling the square root of 2 times the height divided by g. In this case, the range would be given v initial t. This would be equal to v initial multiplied by 2t, rather, my apologies, 2h over g. And so we can square this and say that r squared is equaling 2v initial squared divided by g, knowing that we have the same initial velocity every time because we're using the same amount of hairspray, and that the acceleration due to gravity is of course constant. This would be multiplied by h, and so if we plot r squared versus h, we could obtain a linear line with a slope equal to v initial squared divided by g. And if we were to plot r squared versus h, this is what the graph would look like. We have r squared in meters squared, and we have h, the height, in meters, and we are obtaining, again, that straight line. So this is what the graph would look like. Then for part B, when they want us to actually find the initial velocity, we know that the slope here is going to be equaling 55.2 meters, and this is equaling 2v initial squared divided by g. So we can then say that v initial would be equal to the square root of 55.2 meters multiplied by 9.8 meters per second squared. This would be divided by 2, and we can say that the initial velocity is then going to be equal to 16.4 meters per second. This would be our final, this would be rather our initial velocity. I'll answer for part B. For part C now, we're launching it at an angle equaling 30 degrees. And so now we know that we're launching it at the level ground, so the ground level, and then it's reaching ground level at the end of its flight. So we can say that the change in the y direction is 0 meters, and in this case we can use the range equation equaling v initial squared times sine of 2 theta divided by g. And so if we use this, we have r equaling v initial that we found in part B, 16.4 meters per second. Quantity squared, this is this would be multiplied, my apologies, by sine 2 times 30, so sine of 60 degrees, and then this would be divided by 9.8 meters per second squared, and we find that the range is equaling 23.8 meters. This would be our final answer to part C. That is the end of the solution. Thank you for watching.